This is module 10. I don't know what to do. The last module has last quiz on it. This is module 10. Everything after this module is review. And I have a lot of reviewing to do. But I'm thinking that I might, since it takes me a long time to create, and we have a few things we can still be doing. Like, for example, we have a project to do. That's going to take some time. We have the mysterious integrals test, which isn't an integrals test. It's not a test. I'm just giving it to you to look at. So it's not taken as a test anymore. We have the final. We have review. I have to review from the midterm. So there's a bunch of things for me to do, but generally speaking, there's less to do. Also, after module 10 is over, like when you finish quiz 10, I'm going to lock those grades in, and then I'm going to open up all the quizzes, I think. What do you think about that? In other words, there are people who wanted to see some of the quizzes or maybe try them again, but I can't be having the grades popping up. It makes me crazy. But if I can lock the grades in, then you can go into the quiz and take it as many times as you want and practice as much as you want for the final. So I think the quizzes are good practice for the final, and I want to make them open. So I'm going to wait until the last quiz is done.
Those questions are going to be
It's going to be like, I have to rewrite the final because the final is just like the midterm. It wasn't done with all the speaking stuff in there. So I have to rewrite it. So I'll rewrite it and it'll be whatever it is. It's a lot like the midterm. It's one of those speak 60% of the time. And yes. Am I sharing, Kara? I don't think I'm sharing yet, am I?
No, you're not.
All right, so let's do that. And there's Jacob and Mahir. So I think that will be good to have the review. It doesn't bother me that we end a little, we don't have that much to do. I might even open up the final early. That's what I said. So I might open it up early and let it run all the way until the due date. So if you want to take it ahead of time, you can. But I want to tell you that I get a lot of competition from other classes this time of year. So it's I kind of beat you up in the beginning. We move fast. And then towards the end, it really slows up because you have term papers to write in your other classes, your final exams in your other classes. So I kind of like it this way. But we have a lot to do. So let's talk about how we're going to get that done. So mod 10. Okay. Well, first of all, any questions for mod 9? That was due last week. We went over mod 9, I believe. So mod 9 were these questions. They were just in regular integral questions, and you could do them several ways. What are the ways that we could do integrals? Does anyone remember? Like this guy right here. How do we do? This is compute the area of the integral. What is this? When the function is broken up into pieces, what do you have to do with it? Does anyone remember? One way, so what is a definite integral? What does it mean? It means the something under the something. What? Anyone? Definite integral means what? It's the area under the curve. And in this case, the curve looks like here it is. It looks like this. This is the area that they want. And since they're just pieces that look like geometry of a triangle and a rectangle, you could just do area under the curve by knowing geometry. So this notation, math is a what? Math is a language, and this particular language is saying we just want the area under this curve. And you could do it using geometry. Or this one right here is so easy, it's already in decimals. Decimals can't even do it without spitting out an answer. You know how I get it to stop spitting out an answer? I put a period at the end like that. So when I put the period in, decimals doesn't do it. But if I just hit enter, if I just take that period away, it can't do it. So another way to do it is just have decimals calculated for you. So you've got geometry, you've got decimals calculating it. You also have the, so this one right here, you can't do in decimals or calculate because it's a function of x. So for that one, we use that theorem, which is the fundamental theorem of calculus. So we use the antiderivative. So we say, what's the antiderivative of the integrand thing inside the integral? You find that out. You evaluated it x and you evaluated it 2. It's interesting because Desmos can give us a graph. If I click on this, it'll give me a graph of it. That's the graph of what that is, because this is a function. This is not an area under the curve. It's an area under the curve depending on what x you give it. So if you give the x a 0, it'll be one area. If you give it, it'll be negative actually. If you give it a 2, if I plug a 2 in there, the interval will be 0. Oops. When you go from 2 to 2, your area under 1 point is 0. That. Okay, but it depends. It's actually a function. Okay, you could actually even write something like g of x, define it to be a function, g of x equals. Okay, so you give it an x, you say g of 2, that was 0. G of 2 was 0. Okay, g of 3 is 325. Okay, so it's doing the integral. So you can make the integral function by putting x there, but the only way we can turn that into a function is by using the fundamental theorem. So that's another way to find the area under the curve, is using the fundamental theorem of calculus, which involves finding the antiderivative, evaluating it at the 2 points, the upper limit and the lower limit, and subtracting them. That's what the fundamental theorem says. So it's the antiderivative evaluated at x, and it's the antiderivative evaluated at 2, and you evaluated at x, that just means plug an x in, and evaluated at 2 gives you 80. So that's the function, that's the graph right there that's in purple. 5x to the 4th minus 8. Okay, so we have geometry, Desmos, fundamental theorem of calculus. Oh, see, this one's evil. I think last time I tried, okay. So you have, that's the problem with this problem. What's that you couldn't see before? And I leave it that way. What's the tiny little apostrophe thing mean? It's called a prime. What does the prime mean? It means the derivative. So it says here's a function that's really an integral. So the function is an antiderivative. And then it says find the derivative of it. Okay? So you can do this 2 ways. You could use the fundamental theorem of calculus. I think if you look at the answer, it'll do the fundamental theorem of calculus, and then you get an answer like this, 5x to the 4th, and then you take the derivative of it. Or you could know something. If this is an antiderivative, and you're taking the derivative of an antiderivative, what undoes a derivative? An antiderivative. So if they're undoing each other, what are you going to be left with? Just everything that's in there. If you have a derivative of an antiderivative, you just copy that right down there and you put x's in for t's. But if I do the answer, you'll just see if I go all the way down to the bottom, it's the same. Where is it? Use the fundamental theorem of calculus. Okay, they didn't do it. But if I take the derivative of this, do that next step. It's not here. I didn't see it either. So it's x, it's the 3 comes down, so it's x squared. And then it's minus the 2 comes down, so that's 3x plus 4. Okay, that right there should be the same as this right here, only with x's instead of t's. Okay, so all right. So that is an even one. You need to do the fundamental theorem. Here's another one. This says use the fundamental theorem, so that's just says use it. 6 says this one's just you put this in decimals. Here's one where they give you the area of a shaded region. Okay, for this one, they want the area of the shaded region. You have to make sure if you use the integral, it gives you negative answers. So you have to understand that this isn't geometry. You can still use any of the methods we had before. You can use Desmos, you can use the fundamental theorem of calculus. You can just, you can't really use geometry because these shapes aren't like easy shapes. But once you get the area of each one of them separately, you just add them up. All right. Here's another one. Same thing for this one too. You can use geometry for that one. All right, how about this one? I don't know, right? The same one? Anyway, are we, and then after all of that, we also have to know about average value. Remember, the average value looks like the average rate of change only with the antiderivatives. Or you can find the area under the curve. They give you an interval. You can find the area under the curve and divide it by the limits of integration subtracted. So the 6 minus 2. Okay, that'll give you the average value. And then there's 2 other problems here that had to do with when we had position, velocity, and acceleration. We'd start with position and go to acceleration. Now we can go backwards with the antiderivative. We can go from acceleration down to position. All right. That was the homework from there. Then you had a quiz. Did I go over quiz 9? Don't feel like I did. Let's see. No. Okay. Say something mixed. Okay. So since we're doing integrals, and we already had integrals last time, this is something different. These are derivatives and integrals mixed up. So how would you say this? Again, you should just read from left to right. So what's it say? The derivative of the integral from 0 to of derivative of the integral from 0 to x of the given function of t is the given function of x plus a constant. Yep. So they're just saying f of t that because it's multiple choice and I don't want to give it away, I just say the given function. On the test, you would say f of t. Right? All right. I wonder why that was missed. What was the integral from 0 to x of the derivative of the given function? That's not what it says. You can't switch the derivatives and the integrals yet. Okay, next one. Any questions at home? Jake? Nana?
No.
All right. In this, distance is being measured. Find the average distance from between 2 hours. Okay. So let's I'm going to click on this. And I'm gonna go in here and I'm going to plug, oops. That's the question. Use the integral. Integral to find the average distance from home between hour A and hour B. So let's give me 2 hours. Pick a number, Sarah. 5 and bigger number. Thank you. 5 and 9. So how do we do this? It says use the integral. If you want the average value, the integral is what? I n t. They're going from 5 to 9, so you do 5 to 9, right? They give you the function. It's this f of x. Okay, so I'll just write f of x. Tx. Is that the average distance? 1862? Okay, remember if I draw a line here, watch if I draw a line here. I don't even see it. It's way up there. Between 5 and 9 is way down here. That's not the average value. So how do I find the average value? You have to do what? Divide it by. So I got the area, and how do I find the average height? If I have an area, I don't want the height. I divide it by the what? The length, which in this case is 9 minus 5. Does that look like an average value? Well, it's certainly around the ballpark. Let me just show you what x equals 5 and x equals 9 look like. No. Okay, do you see? I want the average value of the function. Let me take this up. Do you see? I'm talking about that function right there. The average value should be right in between. And so you can see that this is where that average value is. The area above the average value, this little piece, is equal to the area below. Do you know what happens if you get a 70, 80, 90 on a test? Do you know how you figure out your average? This is what I used to do when I was grading papers at Rutgers. This is a fast way to find an average. Yes, if it's a 70, 80, 90, you say, I think the average is 80. And then you look at 70, you say, I'm 10 below. And then you look at 90, you say, I'm 10 above. And then if it turns out that there's nothing left, then you're right on the average. Okay? That's a way to find averages. I guess that's not interesting. But anyway, and then does it say, so the answer here is 465.62. Doesn't say, but that's what the answer would be. Okay. Why did people miss this? Only one person had this problem. This problem has to be, maybe there's something wrong with this problem. Because this is a formula generated problem. There should be a lot of them. Okay, what does the fundamental theorem of calculus do? Let me pick on somebody at home. Hello, people at home. Kara, you're the only one I know who's been able to. What's the fundamental theorem of calculus do?
I'm sorry, I don't have a good answer.
Okay, in the beginning, I was doing what? And I said you could use the fundamental theorem of calculus. What was I doing? I was finding areas. And then to find area, what's the notation for what is a notation for finding the area under a curve between 2 points? It's an integral. Which type of integral? Anybody? What's the integral that finds area under a curve? Anyone? The integral that finds the area under the curve.
Is it definite?
Yes, the definite integral. And it looks, and the notation looks a lot like an integral regular. What's the other type of integral? And that does what? That's not the area, but it's the. No. It's the antiderivative. And so what's the fundamental theorem? It relates the definite integral to the difference of indefinite integrals. Okay, that's what the fundamental theorem does. Okay. All right. I don't know why people get this one wrong, but I think it's because, okay, so here's why people get this one wrong. Because they think I want the area under the whole curve, but what does it say? Read the instructions. Find the area under the function between 0 and 2. So that's not all three of these, it's only the second and third ones. So admittedly, that's misleading because you think because it's shaded in, they want the integral from -1 to 2, but they only want part of it. Okay. Ooh, what's happening between lines 20 and 21? Okay, what happened here? Yes, fundamental theorem of calculus. I see definite integral, I see an antiderivative. Very good. So the first line is the antiderivative, and the second one is using it to find the area under a curve or an integral. So that's the fundamental theorem. So it should say finding the area using the fundamental theorem of calculus. Okay. All right, anyway, we've reached 100%. So it seems like this quiz, either people got it or there weren't a lot of people doing it. It says that one person did it. Is it really only one person that took this test?
I took it.
Are you the only person who took it, Devon?
Yeah,
Were those all your answers?
the first two questions. Like, I will.
Yeah, because there's only 5 of them here, and I know there's more. So this means you're the only person. You got one of them right.
Yeah.
Okay. All right, let's do tonight. I can't help you with it if you don't do it. But that's what I'm stuck with. All right. So go for it. Anything else for mod? This is quiz 9. Anything else for mod 9? Anything? Let me just double check that I'm on track because I know I don't feel like quiz 9 is due until the 12th. What's today? 12th. Okay, so mod 10 is due today. The discussion is approximate area. How about we do some discussion there under the curve? Because the other thing in mod 10 that I need to get to is something called substitution. That's what I need to do. So why don't we break up in our group and try approximate area? Because that's going to be hard enough as it is anyway. So let's start with this. So how do we do approximate area? So I'm going to go to lesson. I'm going to go to my .9. Line 9. We did the area and the average value, right? I don't think I looked at these. So these are areas. I only see 2 because there's only 2 people left. Devon, this is yours, right? Is this due tonight too? This is mod 9. The discussion should be due tonight. Okay, so you found the area under. Oh, look, Sarah answered it. And Nana answered it. So Nana did the math between 5 and 25. there were 15%, not per. Hey, Nana, are you there?
Yeah,
When you're doing an area, you use the X units at times the Y units. There's no per. So
okay.
this would be percent for the Ys and hours, so it would be percent hours. So that would be 16% hours. And Sarah needs to add the word hours. She said there was 16% hours. But why didn't either of you use the average value? So the reason why I put them both in this topic is because that 16% hours doesn't make any sense to you. It can't make any sense. So that's why I do the average value. So what's the average value? So 75, that's the average grade that someone gets when studying between how many hours? 5 and, yeah, so if a person's studying between 5 and 25 hours, they should get about a 75. Do you understand? That's not bad. It says something. If you were to use, let's say, 20 and 25, the average would be much higher. If you're only looking at people that study between 20 and 25 hours, the average grade of those people would be much higher, probably 87 or something. But since you're going from 5 hours to 25 hours, of course it's 75 because there's a lot of people in these, well, there's a lot of people between 5 and 10 hours that those grades ain't so good. And they're pulling the average down. Okay, it's really nice to know. I think that's a good thing to know. If you have a function, it's measuring anything. Melanie, you're a biology person, yes. Don't you think that you would like to know what the average temperature is? Does that ever interest you? What average? Come on, you must be interested in some average in biology. The average size of a ferret. What if you had a ferret and it was 20,000 pounds? You'd be like, ooh, that's a big ferret. But do you know what I'm saying? Like if an animal is too big or small, you would want to know what the average size is. And so if you want to know the average size for ferrets in New Jersey, you could only look at ferrets in New Jersey. But if you want an average of all ferrets, you include them all. You go throughout the whole world and you include ferrets everywhere. That's all we're doing here. We're just talking about people who spend so many hours studying. What's their average grade? Okay, the average grade for people who spend no time studying is very low, or 0 to 5 hours studying is going to be very low, much lower than somebody who's between 20 and 25. Okay, so are you guys going to talk about the average instead of what you did talk about? So Nana, you could do that integral and just divide it by 25 minus 20, 25 minus 5. Is this one's in the equation editor. So divide it, and then you'll have a number 75 that'll be much more better. And you'll say, Sarah, between that many hours of studying, the average grade was 75%. Oh, you say it right here. I'd just delete it. But Nana should add it, and she should add that part, and you should get rid of it because 15%, and it's wrong anyway. It's 16% hours. So you don't want, nobody knows what a percent hour is. That's the problem. Okay, Anusha. So Anusha has an average value of, is this an average number of friends over that interval of income between 20 and 150? So if you make between 20 and 150,000, do you guys have jobs? Anyone here have a job, have a salary? So if you make, do you have like 3 or 4 best BFFs?
Yeah.
Okay. Then that's what it says. If you make this amount of money, you have about that many BFFs. I showed you my iPhone. I make in that range of salaries, and I have 4 friends.
Well, you have 4 really good friends, and then the rest of it.
And I don't know. I probably only have 3, maybe not even. I'm telling you, if I look at my, what's that called, the contacts or whatever. Contacts? What's your favorites on your phone? What's that, when I go to dial it, phone? Yes, see, that's how many favorites I have, 4. I'd say they're all good. Now, my sister's on there, I might take her off. I'm gonna take her off. I'm not mad at her, I just want to talk to her so much. Oh, I'm live streaming. I love my sister. She's the best thing. She's not gonna watch my hours of video to find that. Anyway, Anusha posted it, but no one responded to it in her group. So do you guys know what to do? Can I get? Actually, this is due tonight. This is mod 9 discussions, yes? Okay, so those Sarah and Nana gave good examples for the other people in your group and then for the other group. I guess Devon, someone's gonna have to pick different numbers. Like maybe people study between 25 and 30 hours. But let me go back to lesson. I just want to make sure that I have the right thing too today. So what's due today on the 12th is mod 10 and the discussion. So that area was due last time. So now I think I made it due on Thursday. I want it on Thursday, but at least has to be done today. So what the approximate area is the last one that we have to do. And that gets posted in mod 10. So let's work on that. And how do we get that? Mod 10. Okay, and I'm going to click on approximate area. I'm going to click on the example. So my example is hours and distance traveled. Okay, and I'm going between 0 and 20. That's my time. Okay, now the average rate of change all the way down to approximate area. So when I get to approximate area, I'm going to open this up. Below is the exact area. I don't need the exact area, so forget that. But just for comparison, it says 10,800. Now I'm going to approximate it. So there's the antiderivative. Oh, here's another one. I used the fundamental theorem of calculus. I found the antiderivative. I have a function. It was ax to the 4th, and to antiderivative becomes ax to the 5th over 5. Bx to the was bx cubed, so now it's bx to the 4th over 4. And so that's the antiderivative right there. You have to keep going. So capital F is the antiderivative. If you do capital F evaluated at the upper limit minus the lower limit, you still get that 10,800. But that's not what I need to do in this one. Those are good. They're good for comparison. And actually, you're supposed to do this one, so leave that there. Because that's what you're going to compare it to. So everything should be fine. You don't have to change anything. But here's the summation. This is a summation from 0 to 3,999. If you're going from 0 to 3,999, that's 4,000 rectangles. Okay, and then I'm taking the function, I'm evaluating it at the left endpoint. Plus, this is the incremental difference, which is super tiny because that's whatever the distance is between B1 and A1, you're dividing it by 4,000. So they're super little tiny wafers. And then you're multiplying it by that incremental difference. And remember, Devon, last time I said, if you're just adding up the function, you're just adding up values. If you multiply it by the same thing that you're changing by, what are you doing? You're now finding what? An area. So this is an approximate area. And it's 4,000 rectangles. And look at how close it is to the actual number. 10,800 versus 10,797.5. Close. But let's say you want better. Don't use 4,000 rectangles. All you have to do is adjust this thing. Here's 46,000 rectangles. And you see, I'm so close. If I round it up to whole numbers, I'm already there. Do you see that? It's amazing to me that decimals can add up thousands and thousands of rectangles. Like 100,000 rectangles. That's amazing that it can do that. I'm just saying, but that's technology for you. So if I use 100,000 rectangles, let me not, I don't want it to be exactly the same. I want to, so let me 31,000 rectangles. Nope, that gives me the same answer. Let's go back to 7,000 rectangles. So I'd say, so I have this f of 20 minus f of 4. That's the exact value. And then, so the producer wants to show that, and then they want to show this. And the writer is going to have to change that value up there to 4,000 or whatever it is. Whatever the number is, you have to change that level, let n, that we say n equals 7,000. You have to change this to 7,000. Here, 7. That's what the writer has to do. The writer can't be leaving unmixed, unwritten variables. That's exactly what they're doing. They're calculating this and they're getting 1097 and says, according to the court of regression between 0 and 20 hours, using the 7,000 rectangles. Evaluated at the left endpoints, the trip uses approximately 10,800 mile hours. Okay. Or you could say that what the average is. If you want to, you figure out the average. So in this case, Sarah, you'll use percent hours, whatever it is, to just say it's so many percent hours. You don't have to say the average value is. Just we're approximating an interval. So, all right, any questions on this? Do you think you can do this? All right, let's break up into our groups and do it then. Are you guys all in the same group? Melanie, you're in the same science group that they're in. All right. So one of you gonna pick up the people at home that are in your group? All right, I'm opening up breakout rooms, 2 of them. Okay. Mahir, who's in the group with you? Oh, Kara's here. Kara, Mahir, and Suhave, I think, are all in the business group, right? Jacob and Nana are in the other group. Yes? Are you with me?
Yep.
Jacob's in your group, isn't he? It's in their group? Oh, he'll, wherever he ends up is where he goes. All right, come on, join the rooms. What's going on here? Don't make me still wait. And turn your videos on when you're in your groups. Turn them on.
It's not allowing me in the groups or whatever.
It isn't?
No.
What group, which number do you want to go to? 1 or 2?
I don't know.
1. There you go. I moved you there. See if you can join. And he did. Suhave. Suhave. Blah, blah, blah. Oops. Devon, you're joining so that you can join room 2 and pick up Nana and Jacob. It just died. Sarah has a computer. I think it's best to have one sort of liaison. I mean, we only have 2 groups in this class, but if we had more groups, and you were all on Zoom, it might be a little noisy.
Are you on?
We're doing mod 10. You can do both if you didn't finish. You finished mod 9, so you can go on and do mod 10. But Kara's group did not finish mod 9. Somebody posted something. A new ship, and then so Kara, Mahir, and Suhave have to reply before midnight. But you guys can move on to the just go in and do the approximate. Pick a number of rectangles. Yeah, let's do tonight.
Want 10 is it?
Yeah, this is one. Let's do. Maybe give you more time. But do it now. It shouldn't be. Do it. Get it done. Because this is the last one. What? Well, that's their problem, isn't it?
What is 10 do? Lots of 2 and 5, 5 and 25. We'll say number like. There we go. Are we done?
What? How to say area? Oh, so you're here, right? Though, if you want shaded area on the screen, it doesn't happen in this problem. If you just click the one above it, it'll shade the area for you. The reason why it won't show this one as approximate area, it's the same, whatever it is, this problem here is the same one. It's the same, you're using the same limits. A1 and B1 are the same for either one. So if you want the shaded region, just click on 66. Let me see. Let me join the other group and find out what they're doing. Oh, somebody left. Okay, yeah. Hello, we're back. I have to share screen again. So did you hear what I said, Kara? Can you delete this picture that you have here, this first one? Because I don't think I need that. I only need this one.
Okay.
Approximate area. You had to turn it on. I appreciate that you turned it on. The picture's great. Oh, maybe it doesn't have the limits. Oh, it doesn't have the limits. Hold on. I need A1, B1 from the other picture. So yeah, just leave them. So you're going from 20 to 150 and using 4,000 rectangles. And you're finding out that there are 4. So if you divide that by whatever you get the average number of BFFs, this is BFF $1,000. The units kind of stink here, but. Okay, did the other group post? I don't see a post. It doesn't say there's another post. Hold on. That
Yes, something there.
Oh, there it says it now. Maybe I had to refresh the screen. Oh, look at the post. Beautiful. Okay, so you have the same problem with you that I have with her. Can you write? Oh, you wrote 25 and 5. So I guess I can see it pretty clearly. It's between 25 and 5. Just need to make sure that it's clear to see. And it sort of is. Okay. So did anyone reply to it?
Yes.
Oh, okay. So Melanie, are you going to do speaking or writing? Okay, here's the problem. The speaking is the one that's going to say, according to the, which regression are you using? Quartic? I don't see it, but I think it's a quartic regression. According to the quartic, actually you can see from the antiderivative that it's a quartic regression because that's the 5th power. So it's a quartic regression between 5 and 25 hours of studying. And you're using 30,000 rectangles. Okay, so you didn't do 30,000. Can I tell you why you didn't do 30,000? Because in your formula itself, it says 3,000. So you might as well just change that n to a 3,000 because that n, that formula had an n in it, but you changed the n. So anyway, it doesn't matter what you don't have to, that's not a big deal, but Melody has to say 3,000 rectangles gives me 1515.78. Okay, so actually, Melody, you see this right here? If she's going to edit it, you're just going to, whatever this is, because there should have been an n there. Put the n's back and let Melody edit it. So whatever that n is, so you see how she put 3,000s in? You're going to do that. You're going to take her answer and you're going to put 3,000s in it. If she's nice, she'll give you the link to the decimal sheet so you can just take a picture of it. But just make sure you add the units to the end. Or you type it in as that. So that's the writer and the speaker. Devon, did he leave? No. Devon will figure out what to do. Oh, his computer's broken. Okay. Let's keep moving then. Any questions on this? So they're not bad. These are technically due tonight, but you finished 9, right? 9 is due tonight. 10 I can give you more time on. Did you guys finish 9? Average value? Okay, I see 2 comments under each. There are 9 people in this class. If there's Devon and 2 people and Anusha and 2 people, that's 6 comments. There's 3 people missing. Who's missing? Sarah, you guys? Anusha, did you post in week 9? Okay, so what you have to do, because Devon didn't give you anything else to do, here's my advice to you. Devon gave you the link right here. Could you just click on it? like that, and pick different endpoints. And post the same thing, so you can pick, instead of 5 and 25, you can pick, I like 20 and 25. And then go down here and turn on that average value. So you see, you're talking about the average value there. And then you can just open it up and post, you could just post this, take a picture of this. Okay, got it? And then just post it as a, don't post it under his thread. Give it your own, well, I don't care what you post it. But this is a producer, because they used up the writer and the speaker, you have to do a different interval. But you see the average value? Look at the average value. If you spend between 20 and 25 hours studying, what's your average grade? 9. That's better than your grade, which was only 75. So, and also notice if you spend between 0 and 5 hours, this stuff is really amazing that it does it. But what do you think your average grade is then? Yeah, that's crappy. This is a really neat toy, Desmos, that it changes things so fast. You do not understand how much time you would have spent when we used a graphing calculator. Because graphing calculator doesn't save nothing. If you put all this stuff in, it'll save the data. You have to issue the command every time, and then you have to type it in from beginning to end. It's tedious. Okay, but this is wonderful because you type it in, you can see what it is you're trying to do. Technology, so true. Okay, can I go back to mod 10 now? Okay, so that's the end of those. Good luck. And let me talk about mod 10. It's the last mod. Okay. Okay. So let me just go over the vocabulary. We know what the fundamental theorem of calculus does. That relates the derivative and the antiderivative. That was for mod 9. Okay. We know how to find the average value. It's by doing these things. So that's fine. All right. So what we're going to do now is, so the derivative, what undoes the derivative is an antiderivative, right? So some of the derivatives are kind of special. In Calc 2, they'll undo the product rule, but we're going to undo the chain rule. And what undoes the chain rule is something called integration by substitution. Okay? Now, if you remember the chain rule, remember when you took the derivative of something and there was a function, there was an inside function and an outside function, f of g of x. Remember, you took the derivative of the outside and you left the inside alone, and then you took the derivative of the inside. That's the chain rule. Here's the thing. I remember I kept telling you this. I kept emphasizing it, and I hope you remember it. I said, do you remember when you leave something alone? You leave it alone, and it appears in the answer, right? So if you had e to the 5x plus 1, that 5x plus 1 ended up in the answer because it was a chain rule. It'll end up in the answer. So what happens is, what we're going to do is we're going to undo that. And when we undo it, we're going to have something like an integral here. Integral. Why isn't it doing it? Integral. There. So we'll take the integral and the integral derivative. So to go back to where we started from, okay, we'll have something that looks like this. And we're going to make a substitution. We're going to say, well, what was that thing that we took the derivative of? Anything in a parentheses would be good. So you remember the e to the x one, the e to the 5x plus 1 that was on the test? Well, anything in an exponent is good. And what else is good? Anything in a denominator. So those are the sorts of things you're looking for. So what are the best candidates for substitutions? When you have a function inside of parentheses, obviously. If you have something in an exponent, or you have something in a denominator. Okay, so that's what we're looking for. We're going to look for parentheses that have a function inside of them. We're going to look for denominators or exponents. Okay, now it says, what letter is used for integration with substitution? That's the letter U. Okay. All right, and then I'll save these for next class, but those are things. So let's start off with the substitution that I can show you here. I'll just do it right here. So let's start off with something where I know, give me any function on the inside. What do you want? Sine of x? What's the derivative of sine of x?
So, there it is.
Derivative of sine is just cosine. Okay. So if I want to undo this function, what I'm going to do is I'm going to say, and let's just say the derivative is, I'm going to square this. Okay. So that's something to do with the outside function. So what I'm going to do with the substitution, I'm going to say u equals the inside function here is the sine of x. Okay. And then I'm going to say, what is du equal to? Du would be the derivative of sine is what? Cosine x dx. I want you to see that this cosine x dx is the same as that cosine x dx. So when I do this integral, paste it, I'm going to take the cosine of x and I'm going to replace it with du. And I'm going to take the sine of x and I'm going to replace it with u. Can we do the antiderivative of u squared? What's the antiderivative of u squared? U to the, no. I have to add power. It's u cubed over 3 plus a constant. Okay, we can undo it. By using a substitution, we can undo it. And now the question is this. We didn't have a u in the problem in the beginning, right? We didn't have a sign. We had signs of x, so why are we ending with u's? So what do we have to do? We just have to go back. We have now the back substitute. So in other words, you have to say u equals the sine of x. So you have to replace all the u's with the signs of x's. So now I get that the answer is the sine of x raised to the third power divided by 3 plus c. Okay, that is an integration by substitution. Okay, let's see what we have in the homework file, the mod technical. Okay, so in this, so now they're giving you harder problems. In this problem right here, that you're given in a homework, they tell you what the substitution is. It's right there. U is x to the 9th plus 7. So all I'm going to do is copy this whole thing, put it there. And this right here, that's going to be u. And the square root of u is the same as u to the 1/2. We can integrate that. That's fine. The 1/2, right? Okay. I can't mix the variables. I can't have this x to the 8th. So let me move that over here and put it next to that. X to the 8th dx. Is that going to be a du? So I'm going to take this u here, copy, and I'm going to take the derivative of it. It's the derivative of x to the 9th. 9x to the 8th. What's the derivative of 8? That's nothing because it's constant. And then there's a dx there because it's a differential. So I have x to the 8th right here. I have them. There's a 9 in front. What can I do with that 9? I can move it to the other side, maybe. How do I get it to the other side? I just divide both sides by 9. So divide this by 9. Divide that by 9. Okay. Now I have x 8 to the 8th. Now I'm going to replace it with this. I'm going to take that x to the 8th dx, and I'm going to replace it with du over 9. Okay? And I could do something else with that. I can take the 1/9 out. Well, I can just take the 1/9 out, 1 divided by 9, and I can get rid of this. Can you give me the antiderivative of u to the 1/2? Anyone? Suhabe? What's the antiderivative of? So this is gonna be 1/9 what? What's the antiderivative of u to the 1/2? U to the what? The derivative would lower it by a power. The antiderivative does what? But here, since your audio is on, can you tell me what the antiderivative of u to the 1/2 is? U to the. Come on, somebody. Nana, u to the 1/2?
Huh?
U to 1/9?
No, the 1/9 is just a constant. What do? You add 1. So what's 1 plus a half?
1 and 1/2, right?
Well, I could say 1.5, that's fine. And then what? This is an antiderivative, so it's what? After you raise it to a power, you have to do what? So by it's comes from something. 1.5. Okay. And then I have to do plus C. Now I'm not done yet. I can clean this up if I want to, but I'm just gonna leave it the way it is, except I can't have u's. So what was u equal to? In the beginning, what was u equal to? Did we not write it down? There it is. X to the 9 plus 8. So I'm gonna copy that. I'm gonna replace my answer. I'm gonna replace it with x to the 9 plus 8. Like that. Okay. And that's the answer. Or I can clean it up some more if I want that 9. What's 9 times 1.5? 9 and 4.5 is 13.5. Okay. That's how you do a substitution. If they tell you the substitution, thank you. If they tell you the substitution, you're going to replace, they're giving you the square root x plus x, that's going to be right there. That's your substitution, that's going to become u. The rest of the stuff, hopefully, the square root of x and the dx, hopefully that all goes away. So let's take, if we do u is that, what's du equal to? What's the derivative of x to the 1/2? Oh, sorry, this is x to the 1/2. What's the derivative of? Now, this is a derivative, not an antiderivative, it's a regular derivative. Negative 1. Which is another way of saying 1/2. No. Oh, did I wrote the thing? Sorry. 1/2 x. So that's 1 over. Oh, I forgot the dx. Dx. That's 1 over. Well, that's 1/2 times 1 over square root of x dx. Okay, do you see a 1 over square root of x dx somewhere in this problem? You do, it's right there. Okay, square root of x dx in the denominator. So the thing is, I have that accounted for, but I don't have the 1/2. How can I get rid of the 1/2? The other, it's close, keep going. I don't want to divide it by, I divided by half is the same as multiplying by 2. So I'm going to take that up, and I'm going to bring it to the other side as a 2. That's how I bring the 2 up. Okay, So I'm gonna replace this constant, that right there, which is the same as, let me just rewrite it this way. Just gonna take this square root of x and move it to the side. Put it here. Okay. So this becomes, when I do all the integration, this becomes. Get rid of this. I'm gonna get rid of this. And I'm just gonna have 2 du. Okay, now can I solve that? So it's gonna be 2. What's the antiderivative of u to the 5th, Davon? U to the antiderivative. Antiderivative.
To the 6 over.
Yeah, 6 over 6, thank you. Plus what? Let's see. Am I done? No, what do I have to do there to finish it up? Make it, and I remember the substitution was the square root of x plus 6. I have to replace the u with that. That's the answer. Okay. Now, this one, they're not telling you what the u substitution is. What do you think the u substitution should be? Remember I told you what's the best candidates? Anything in parentheses, anything in an exponent, anything in the denominator. Now, all of this is in the denominator. But only this is inside the square root. That would be like being inside a parentheses. What's the, so let's just guess at something like u equals cosine x. What's du then? It's derivative of cosine. Okay, we have a sine of x and a dx, we just don't have the negative. So what can we do to get rid of the negative? What can we do to get rid of the negative? Divide by negative over to the other side. So I have this. I have the sine of x dx is minus du. So this whole integral is going to become. I'm going to put a u here. I'm going to take the sine of x and the dx, and I'm going to replace it with minus du. Where'd that 9 come from? Oh, I know what to do. Okay, can I integrate this? Just can I just take some stuff out? Can I just say minus 7 over 3? And then can I say integral, oops, wrong, so minus 7 over 3, integral. This 1 over the square root of u, because it's u raised to what power? Negative 1/2. That would du. Okay. Can we do this? Can we do this integral now? Yes, and what is it? Minus 7/3. What? U to the what? 1/2, thank you, divided by what?
7/3.
Divided by what's that same thing, 1/2? Plus what?
C.
So here's another substitution, another problem, and you have to ask yourself, do you see a function? I just want to dissect this a little more. I'm going to copy it over and put it here. Do you see a function inside of parentheses? I see a lot of parentheses, but you see a function inside? By the way, that's supposed to be squared. Okay, do you see a function inside of parentheses? I see an x inside of parentheses. I see a cotangent x. What's the derivative of cotangent? Do you remember? No. Derivative, the differential, it's going to be cosecant squared of x. The x, I think it's negative. I think it's minus. Okay, do I see any of those things there in my problem? No, I do, because I'm looking at it. Okay, so I'm going to replace this cotangent with a u. I'm going to leave this, I'm going to take that 6 and I'll put it outside because it does not doing anything for anybody. There's 6. But you see the minus cosecant squared of x dx? All of that I can replace with what? Minus cosecant of x dx is just du. So I'm just going to take this, get rid of it, take this, turn it into a du. Can we do the antiderivative of the sine of u?
This, yeah.
Yeah, what is it?
Cosine.
I think it's minus cosine. Plus what?
See,
Thank you. So now, am I done? What do I have to do? No. There was no u in the original problem. So what is u equal to?
cosine.
So that's what I put here. Okay. 15 is really hard. Or not 15, 5 is really hard. No, you can. I'm not going to ask you this question, but it has to do with the derivative of inverse secant being like this. So you use u equals x to the 7th, you can see it could look like that. Okay. How about number 6? This, I'm looking at it and I'm seeing parentheses, x squared plus 4. And the derivative of that would be 2x dx. So this does look like a good candidate. Okay. But I could just put this in decimal. See that thing I told you about, put a period there? Take the period out and get 0. The answer is 0. I'm going to discuss this more next time because these are integration. So that's an integration. That's an integration with substitution, but I don't want to do it yet. How about this guy right here? This is another one. 7 is another one that uses inverse sine. That same formula for inverse sine. Okay, so I'll let you do that. 8 is another one that's a definite integral, so we'll have to talk about 8. And we'll have to talk about 9. And 10 next time. So anyway, what we've learned to do is to do substitution on homework. Hold on. We're doing substitution. So let me just my notes for substitution. It's integration by substitution. So this is my handwritten sloppy notes about it. But what you can do is get to antiderivative. You have to figure out what the substitution part is. So if you have e to the 2x, 2x is the thing you're going to substitute. If you have cosine of x squared, then x squared is, or x cubed is going to be the substitution. If you have a sine over cosine, you use the denominator, which is cosine. Okay. All right. These are things in parentheses. All right. One thing I want to say though, before I let you go. So what's horrible about Calc 2? Why is it so awful? Are you taking Calc 2? But it covers Calc 2? Oh, because you can take it there, probably. Oh, I don't know then. So Calc 2 is going to have harder integrals. They're going to spend the first half of the course working on, you know what? So let me tell you about Calc 2 a little bit. So I used to teach Calc 2 and I used to lure people into staying in Calc 2 with how fun it was going to be. You know, you could drop a course the first 2 weeks, get your money back, or first week, you get your money back. So I would show them all, I'd bring in a cake. And there was this integral on how to figure out what the surface area of a cake was, so we could put icing on it. And then there are ways of figuring out the volume of the cake that involve cutting the cake into what's called shells. So instead of cutting into wedges like you would cut on a cake, you cut little circles out of it. And so everyone gets a ring of cake. And it was kind of fun. It was fun class for the first 2 weeks. And then once you're stuck in the course, then it's all this complicated integral stuff. And here's an example. The integral of 1 over 1 plus x squared is just inverse tangent. That's what it is. It's the antiderivative. But if you have something like x over 1 plus x squared, it looks exactly the same, only there's an x there. It's not inverse tangent, it's a substitution, like we're just doing. Okay, and if you have x squared over 1 plus x squared, in order to solve that one, you do a long division. And if you have an x cubed over x squared, you do a long division, and then that turns into a substitution and a regular integral. But you end up there, all these integrals, they look exactly the same, except a little number here and there, but they change dramatically. And that's the thing about Calc 2 is it's all about finding. So here they all are written next to each other. They're all so very different, and yet they look so very similar. And so this is why Calc 2 is a tedious course, because first they'll show you how to find the volumes that we're using washers and the volumes using spheres, and then they'll do surface area. Those are all very useful formulas. And then they'll go into the table of integrals and where they come from, and that's tedious. Okay? But they use substitution a lot. Sometimes, there have been times in this school where substitution was taught in Calc 2. Okay, but honestly, calc substitution is the last thing we need to finish in this course. And my students are really good at it when they leave. So when they go into Calc 2, there's sort of an advantage because a lot of the Calc courses are a little slower on integration. But integration is what you need in Calc 2. Okay? All right. This video is here if you want to look at them. And I'm going to take attendance by asking these questions before you leave. Who wants to answer the first question? What is math? Sarah says a language. Very good, Sarah. You may go. What is pre-calculus? Not Sarah. Anyone? Study of functions. Thank you, Davon. You can go. What is calculus? Study of change. Okay, Melanie, she's gone. It's Melanie, Melody. Your name is Melody. Melanie, I'm saying Melanie, but I'm writing Melanie. Okay. Thank you, Melanie. Okay. Mahir, what are the two rates of change?
Average rate of change,
And
instantaneous.
very good. You can leave. Suhabe.
What
What-
was the question? Can you hear me?
What are the two types of integrals?
The two types of, sorry, what was that?
Of integrals.
I'm not sure.
Are you definitely sure you're not sure? Or are you indefinitely sure you're not sure? What are the two types of integrals? I just gave you a hint. Definitely sure? Definitely sure. The two types of integrals. If you look on the list of answers, it's there in mod 10. Anyone else know what the two types of integrals are?
Definite and indefinite.
Thank you, Dana. You can go. So Hubby can answer this question. Which one of them finds you area, definite or indefinite?
Definite.
Thank you. You can go. Jacob, you're the last one. What does the indefinite integral tell you? I can't hear you. I'm waiting.
Yeah, sorry. I'm not sure. Give me a second.
Gonna give you a second.
What was the question again?
What does the indefinite integral tell you?
The antiderivative?
There you go, Jacob. You can go. Have a good day. I'll
too.
see you. I'll see you on Thursday, maybe.
All right, bye.
Bye-bye.